Hello and welcome to Physics Doctor. My name is Dr. Ghanshyam Tejani and let's start. Chapter number 9, Mechanical Properties of Solid. The similar content is covered in JEE NEET, Unit number 7, Properties of Bulk Matter. And this is session number 3 and we are targeting elasticity. The session number 1, we covered tensile stress, compressive stress and the related examples. In the session number 2, of course, it was on elasticity, Hooke's law. We solved example number 1 to 11. And in this session, we will be continuing this example. So let's start. So this is our example number 12. And it is like that, a wire of length 1 meter and area of cross section 4 multiplied by 10 power minus 8 square. Increase in length by 0.2 centimeter when a force of 16 Newton is applied. Value of y for the material of the wire will be, so we need to find value of y that is known as Young's modulus. See here the given data is like that. One wire is given, say for example this is our wire having length is given, a length is given 1 meter and the cross section area maybe whatever section may be there. Suppose it, if you see from this side, right hand side, so the section area, that area is given 4 multiplied by 10 power minus 8 meter square. Now we know that there are forces are applied on this. Say for example, two pull forces are given, and because of that, there is an increase in the length. Say for example, this length, after increase of this load, there is some increase of length. We know that we use either delta L or small l for that. And that value, it is given 0.2 centimeter. If it is given in centimeter, we need to convert this into meter. And the force, and because of what force, this increase is seen, so that is given 16 Newton. We can take F is equal to, or P is equal to 16 Newton. And we need to find value of y. Y is a Young's modulus. Y is a Young's modulus. Example is very simple and it is from Hooke's law, elasticity. So first, we always identify given data. So as I mentioned earlier that a wire of length 1 meter is given, so we can take L is 1 meter. Then area, cross section area is given 4 multiplied by 10 power minus 8. So this is cross section area A, 4 multiplied by 10 power minus 8 meter square. And because of that, there is an increase. This length is increases, right? This length increases. So that is delta L 0.2 centimeter. As I mentioned earlier, we need to convert this into meter. So here, you just need to divide this by 100. Just need to divide by 100. So it gives us 0.002 meter. The centimeter, it is a 100th part of meter. Centimeter is equal to 100 part of meter. Say for example, 1 meter is equal to 100 centimeter and equal to 1000 millimeter. You have to remember all of these items, right? And this is load which is applied, and because of that F is equal to 16 Newton, and we need to find value of Y. So these different options are given here. We need to select which one is the correct one. Let's see. So we know that equation stress sigma is equal to force by area, strain is equal to change of length to the original length, and as per Hooke's law, sigma is equal to YE, and we need to find this value of Y. So we know that sigma is equal to YE. What is sigma? F by A. What is E? Delta L by L. Let's put this value here. F by A is equal to Y delta L by L, and we can take y on the one side. So y is equal to f multiplied by L. L will be in the opposite side and divided by A divided by delta L A. So now see, we have everything here. F, is it given? Is F given? Yes, of course it is given 16 Newton. L is given 1 meter. Delta L 0.002 meter, and the area is also given. Area, it is given 4 multiplied by 10 power minus 8 meter square. So let's put all the values here. And our answer, we can just simply solve this. 4 multiplied by 4, so divide by 4, that become 4. Can have 2, so it become 2. 8 power minus 10, here it is 0 minus 3, so it become 11. So answer is 2 multiplied by 10 power 11. Which one is the correct? You select A, B, C and D, and our answer is C. This is the correct answer. This is example number 13. A thick uniform rubber rope of density 1.5 gram per centimeter cube and Young's modulus 5 multiplied by 10 power 6 Newton per meter square has a length of 8 meter. When hung from the ceiling of the room, the increase in length of the rope due to its own weight will be. Let's see here. Options are not given. Say for example, this is our ceiling of wall, and here at somewhere, maybe fan, maybe there, whatever, it is hanging. This exactly assume that it is a vertical, the thick uniform rubber rope. This is a thick uniform rubber rope of density is given. Of density, you can write density symbol, rho 1.5 gram per centimeter cube. And Young modulus, it is given Young modulus, we specify by capital Y. 5 multiplied by 10 power 6 has length. So we know that length is equal to L. 8 meter when hang from the ceiling of room. Say for example, this is our ceiling of room, and because of this, in the increase in the length of rope due to its own weight, because of its own weight will be. So see, this rope, the density is given, right? From the density, can we find what amount of mass offered? Because of this rope? So we know that mass is equal to what? Density is always like kilogram per meter cube. If you wanted to have mass, then simply density multiplied by volume of this rope. So it gives us mass. And if you multiply mass multiply by gravity, so it gives us force offered by this rope. So let's repeat again. A thick uniform rubber rope of density is given rho 1.5 gram per centimeter cube. See, if it is given gram, so we need to convert this into kilogram. We know that 1 gram, or you can say 1 kilogram is equal to 1000 gram. We can take inverse also. 1 gram is equal to 1 by 1000 kilogram. So this is the first conversion. We can see here 1.5 divided by 1000, and centimeter, again 1 centimeter if we take is equal to meter. What should be meter? We know that meter is very simple to convert. Meter is equal to 100 centimeter. Whenever you have confusion, you can follow this. So meter by 100 divided by is equal to 1 centimeter. If it is square, so it should be square, that should be square. So 10 power 6. So it should be here, it should be 4. And we may convert this. So it is a cube, so therefore it is not square, right? It is cube. So this is correct. 10 power 6. 10 power 6. We can simplify this. We can simplify this, right? 3 power 3 will be cancelled, so it become minus 3. And here the final solution is 15000 kilogram per meter cube. And y is given, directly given, no conversion is required. Y is 5 multiplied by 10 power minus 6, and length is given 8 meter. Here there is no conversion is required. Now what next? See, we need to find here the force, which is because of its self weight, So we know that mass of the rubber is equal to, as I mentioned earlier, density multiplied by volume. If you want to find mass of any body, always it is density multiplied by volume. You have to use this at many a times. And if you wanted to have, if you required weight, just multiply by gravitational force, or it is called as a gravitational acceleration. We can get force extracted by gravity. F is equal to rho v g. Now what? See, we know this equation. Stress sigma is equal to F by A. Strain is equal to delta L by L, and sigma, Young's modulus. Sigma is equal to Y epsilon. So this is from Hooke's law. What next? See, we already derived this equation. Let me derive. Sigma is equal to F by A is equal to Y epsilon delta L by L. Right. So if you want here, we need delta L change of length. So we can write delta L. We can take this opposite side, F L, and divided by A Y. You can take this Y on the opposite side. Right. So this is a very simple conversion. It is always required whenever we go with stress strain equation. So this equation, now we have delta L is equal to F L divided by AB. And now the important term, it is here. So see, the weight of rope can be assumed at its midpoint. We will be assuming one data, that is the rope weight, whatever total rope of weight, that will be assumed at here at center position, at midpoint. So now extension of length. See, if we assume here weight of this rope at mid position, the total weight, if we are assuming at a mid position, right? See here, if we assume at end point, so it becomes 0. At the top point, if we assume here, so it will not having any expansion. It is not having any expansion. So at middle position, if we assume, so we can have a combination of the upper portion and lower portion. Both will be there, and resultant effect can be get easily. So here we see this equation. This equation is true when increase of length for this entire L. But in this case, we are assuming mass at mid position. That means effective length should be L by 2, half of this wire. Effective length should be half of this wire. So therefore, whenever you find L, so here L, we just need to put L by 2. L has to be replaced by L by 2. So let's put F is equal to rho Vg. F is equal to rho Vg from this equation, and small l is equal to L by 2, or you can say capital L is equal to L by 2. Putting these values here, you can find rho is equal to 1500. All the values are given, right? We can have all the conversions because volume is equal to area multiplied by L. So we can have rho multiplied by A L G L by 2 divided by A by. A will be cancelled, and L square will be there. So rho L G L by 2, and therefore final solution is 9.6 10 power minus 2 meter. Is very simple example, isn't it? Example number 14. A wire of length L, area of cross section A, is hanging from a fixed support. The length of the wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus. We need to find value of Young's modulus. Why? We have four options here: A, B, C, D, E, not E. And the most important, the question was asked in NEET 2020. So here, what is given? So say for example, this is our top portion from where one wire of, it is assumed that straight wire, one wire with length L having cross section area A, it is hanging from the fixed support and length of wire will be changed to L1. Say for example, this wire, the similar wire which changes to L1 when the mass M, if it is suspended, or you can say mass is added at the end of the portion, mass M is suspended from its free end, so it become L1, right? So this condition is given. We know that because of increase of this, so increase of length, that become always original length is L, new length is L1. Original length is L, new length is L1. So if you want to find delta L, increase of length, that become what? L1 minus L. L1 minus L. Right? So very simple question is asked here. Let us just solve. So increase of length, that is L1 minus L. Increase of length, that is L1 minus L. And we know this all the equations. Stress is equal to F by A. Strain is equal to delta L by L. Sigma is equal to Y multiplied by E. Let's put the values of here. So sigma is equal to F by A and delta L is equal to, not delta L, epsilon is equal to delta L by L. Now I think this become very simple. Now it is just put here. Y is equal to F L A. What is F? Mass multiplied by gravitational acceleration. What is L? It become L1 minus L. Put this value here. Do we have solution? MGL. So this A is not correct. MGL A L1 minus A. So answer, solution number C is the correct answer. See, this kind of questions you will see in the NEET and JEE examination. Sometimes it seems very simple and actually they are. Let's go to next example. Example number 15. Again, it is NEET 2018. I think you should pause the video here and you should try this example by yourself and you may compare your example. Example number 15 says, two wires are made of the same material and have the same volume. So two wires are made of by similar material. If the similar material, that means its Young's modulus are common. Both are having equal Young's modulus and have same volume. So total volume means both the volumes are having equal. Right? The first wire has cross section area A and the second wire has cross section area 3A. First wire is having cross section area A. Second wire is having cross section area 3A. Let's have this. For example, this is wire number 1 and the wire number 2, it is having larger cross section area, so we can make it somewhat thicker. If this cross section area is A, for the wire number 2, this becomes 3A. Right? Young modulus is common for both the cases. Volume is also common for both the cases. If the length of the first wire is increased by delta L, so this first wire length is increased. The first wire length, if it increase, say for example delta L, by applying force F, right? By applying force F, If this wire length increases delta L, how much force is needed to stretch second wire by the same amount? If this also getting second wire, it is getting similar delta L. So what should be force? Solutions are 4F, 6F, 9F, and F, and the question was asked in NEET 2018. I think this question must have been understood by you. Let's solve. So first is given data. Let us assume first cross-section area is A having 1. So A1. For the A1, value is given A. Value is given A. Fine. A2 for the second of second section, for the second section, or it is A2 is equal to 3A. It is equal to 3A. Then, as I mentioned here, made of the same material and have same volume. So V1 is equal to V2. And here material is same. That means Young modulus is also equal. Young modulus is Y1 is equal to Y2. Right. And it is here also given that delta L1 is equal to delta L2 is equal to increase of length. So F1 is given F, and what is F2? Why? Very simple. So we know that sigma is equal to F by A, strain is equal to delta L by L, and sigma is equal to Y E. That equation we know very well. And if you wanted to have its volume, for any volume, V1 is equal to area multiplied by L1. Area of the first wire. Area of first wire is A, length is, let us assume, L1. And similar for the second wire, V2 is equal to VL2. This is our separate example here. This section number 1 that is having area A, and let us have it is having length L1. So we know that volume is equal to area multiplied by length. So for 1 that become 1, and similarly for 2 it become, because area is 3A, here area will be 3A. 3A multiplied by L2. Of course L2 should be less than L1. So this is a very simple one. So both have similar volume. That means what? V1 should be V2. V1 is equal to V2. That way you can write AL1 is equal to 3L2. Can we remove this A? Of course. Therefore, L1 is equal to 3L2. L1 is 3L2. So we got one equation. We got one relation from that. Second relation we can find. See, both the cases delta L, increase of length is equal. For both the cases, increase of length is given equal. Therefore, we can write F1 L1 by A1 delta L. You can write here 1, you can write here 2. That is okay, fine. Both are equal. And also it is given material is common. Therefore, Y is also common. Y is also common. We can put the values here. We can put values here. And F1 is equal to F. What is F2? What is F2? Put the values here. Here it become F3, L1 and L2 you can cancel out because we know the relation between them. Increase of length is also similar. Increase of length is also similar. Area is common, so you can delete this all. So it become F multiplied by 3 is equal to F3. So F2 is equal to 9F. F2 become 9F, and it is very simple. So C is the correct answer. C is the correct answer. Solution number C. I think you must have got the similar answer. Example number 16. So this example was asked in JEE 2019 means. Why don't you pause the video and solve this example by yourself? That's all. Young's modulus of two wires A and B are in the ratio of 7 to 4. Wire A 2 meter long and has radius R. Wire B is 1.5 meter long and has radius 2 millimeter. If the two wires stretch by the same length, for a given load, then the value of R is close to. Four options are given. A is 1.3 millimeter, B is 1.5 millimeter, C 1.9 millimeter, and D 1.7 millimeter. Asked in JEE 2019 mains. Okay, let's solve it. So see, first Young's modulus is given, so we can take YA, Young modulus, YA2, YB. This ratio is given. See, 7 to 4. Let's assume A for the first wire, B for the second wire. So first data is given like that. So we can have YA by YB is equal to 7 by 4. We can write that. Then next is wire A is 2 meter long. So what we can write? We can write LA gives length A is 2 meter long. It is mentioned here. And has radius R. So we can write RA for the wire A. Small A or capital A both are equal. So RA is given radius R. And similar is given for LB. LB is given 1.5 meter and has radius, let's say radius RB. Here it is given 2 millimeter. Right? If the two wires stretches by the same length, true wire, that means if the first wire is having, this is LA length, second wire, it is having LB length, and increase in the length, and the increase in the length is, suppose it is given equal. So delta L1, delta L2 both are equal. Both are equal. So delta LA is equal to delta LB are given equal. If the two wires stretch by the same length for a given load, right? That means it is load is also given equal. FA is equal to FB. Load is also equal. So what should be value of this capital R? Radius of the first wire. Fine. So we know that our universal equation, stress sigma is equal to F by A, strain epsilon is delta L by L, and sigma is equal to Y by YE. Fine. So what is given here, we just need to play around this only. Delta L is equal to delta L, A is equal to delta L, B. So we know that delta L is equal to, just putting this value here, so it becomes F L by A Y is equal to delta L. We know that value, these values are very well known to us. So let's put this all the values. So what it become? FA is equal to FB. Can we cancel this out? Of course, we can cancel out. If you want to find area, radius is given. So what is this? Pi by 4 d square, or we can use pi r square, So for the first, it become pi r a square. For the second, pi r b square for the radius. Then what next? YA, YB, YB. Ratio of Y and YB is given. So we can put YA is equal to 7 by 4 YB. So YB, that also we can cancel out. We can put in place of RA. Capital R, RB, 2 power 2. We just need to solve this. Example now. So R square is, we can have solution for that, and R become 1.7 millimeter. R become 1.7 millimeter. So answer number D is the correct answer. So answer number D is our correct answer. You must have the similar answer with you. Now we are waiting for the next question to come. And this is our example number 17. Two wires A and B of the same material have their length ratio 1 to 2. Length ratio is 1 to 2. diameter in the ratio 2 to 1. If they are stretched with the same force, the ratio of increase in the length A to that of B will be, right. So here what given? It is given two wires, say for example A and B are given. This is wire number A, this is wire number B is given. Then what next is given? You can take, let us assume wire A, B, or you can say this is 1, this is 2. You can assume A or B also, right? So first is given, right? The material length ratio is given, 1, 1 to 2. Ratio is given 1 to 2, right? So L1 by L2, you can take L1 by L2 is equal to 1 by 2. So we can write L2 is equal to 2 L1, fine. And the diameter in the ratio is given. So say for example D1 divided by D2 equal to 2 by 1. Therefore we can write D1 is equal to 2 D2. So we can see here there are two examples are L2 is 2 L1, 2 D2 is equal to D1. If they stretch, right? So two wires are the same materials have their length. So Young modulus is also similar. If they are stretched with the same force, the ratio increases in the length will be, right. So increases in the length, it is given equal. If they are stretched with the same force, the ratio of increase in the length, it is to be find, and F1 is equal to F2 is given. So we can have, this is not required, this is not given, fine. So stress sigma is equal to F by A, strain is equal to this equation, we know that delta L is equal to FL by A by that equation also we know. So here we can take ratio of delta L by delta L1 by delta L2. So we can take this ratio and so equal, we can put both the forces are equal. So we can just remove this F and F both. L1 by L2 length we required A y divided by A2 y. So A is pi by 4 D1 square, A is pi, and material is similar. So this y will be cancel out. So y1 equal to y2. Pi by 4 should be cancelled out and solution will be L1 by 4 D1 square, and we can put here values of L1 L2 ratio. We can cancel out this, we can cancel out this also, and our solution become 1 by 8. Solution become 1 by 8. So our solution is C 1 to 8. C is 1 to 8 is our solution. So here we are at example number 18. The length of an elastic string is a meter when the longitudinal tension is 1 Newton. Say for example the elastic string without any stretch. Say for example it is having length L and it is stretched. If it is stretched with 4 Newton, so that become A, length become A. If it is B meter, when length is become B meter when it is applied some force 5 Newton, the length of the string in the meter when applied. What is the length? What should be the length when the force is applied? When the force is applied, 9 Newton. So option is A is A minus B, 5B minus 4A, 2B minus A by 2, and D 4A minus 3B. Right. So see, we need to consider this two at our main component, and based on that we need to solve it. So here we can find the original length. It is A, and with the first increase, when the load is applied 4 Newton, so say for example it become delta L of for the A case, and the similar is applicable when it is applied, so it become delta LB for the case number B, right, for the case number B. So we know that when it is A, so it become, let us assume FA, and when it B, let us assume FB. So A is equal to L original length plus increase of length delta L A, and B equal to L plus delta L B. L is original length plus increase of length, it is should be there. And for the C, similar cases here, right? Similar cases here. C is equal to L plus, or we can write this L plus delta L C. Not it is A, but it should be C. If Fc is 9 Newton, if Fc is, this is Fc is 9 Newton. So here it is given, the area is similar, there is no change in area, cross section area. Why? Because it is similar material, right? For all the cases, fine. So we know that sigma is equal to F by A. Strain is equal to change of length to the original length, and sigma is F by F. So F by A is equal to Y delta L by L, and we know that delta L is equal to, we can put F L and here delta L A, right? So we can put Y or delta L, whatever it is required. As per now, we require delta L, change of length. So first, we know that for the first case, A is equal to L plus delta L A. So can we put here this equation? FL by AY, FL by AY, where FA is 5 Newton, length is original length, so that is to be considered here, and A cross area, Y is Young's modulus. And similar we can find for the B. L, only F is changing, that's what it becomes 5L. We have two equations now. Let's now erase all the things. So let us just simplify this equation and let us assume some value L by AY, both are constant, so let us assume the C. So our equations become like that. A is equal to 4C, L plus 4C, B is equal to L plus 5C. Can you get L in the power? L is equal to A minus 4C, and similar here, if you put this value of L, this equation, so B become 4 minus 4C plus 5C. If you take C on the opposite side, it becomes C. So C is equal to B minus A. C equal to B minus A. C is equal to B minus A. Do we have solution for C? Yes. Definitely we have solution for C. Definitely we have solution for C. So L is equal to A minus 4 B minus A. If you put here the values in the case of A, this equation, from this equation, right? We can put value of C here, A minus 4 divided by B minus B minus A. And similarly, you can just simplify this. So L become 5A minus 4B. L become 5A minus 4B. Now what? We have the length of string 9 Newton. So we know that C is equal to L plus delta L. And for that, we can put here FL L by AY, original L. What is original L? 5A minus 4B, 5A minus 4B plus 9B minus A. Just simplify it. So it becomes 5B minus 4A. Do you have solution? Yes. B is solution 5B minus 4A. So answer number B, it is the correct one. Answer number B is the correct one. Thank you very much for watching Physics Doctor. Please be with me.